welcome to this revision video. In this video today we're going to be looking at the reactions of the group 1 metals, otherwise known as the alkali metals, with water, and we're going to be looking at some of their properties and also the differences in their reactivity as you go down the group. Now in class this will only ever be done as a demonstration because it is quite dangerous. These are very reactive metals and there would normally be a blast screen in between you and the person doing the demonstration. This is quite a common question on exams, so asking about safety precautions and putting a blast screen or a protective shield, if you want to call it that, between the demonstration and the audience is a really good answer for that kind of question. So first what we're going to do is get our metals ready for the experiment and also take a look at some of the properties. Now I'm going to start with lithium, which is up at the top of the group, and it's stored in these jars, and you can see that they are stored in a liquid, so they are stored under oil. Because they are so reactive, they will really quickly react with oxygen, react with water, things like that, so they're stored under oil to protect them a little bit from reacting before we want them to. So I'm just going to get a piece out. Okay, and I'm going to dab it with a little bit of paper towel because it is quite oily. And then I'm going to cut it into a slightly smaller piece before we do this reaction, because this is quite a big chunk. And you can see as well, if you have a look, the surface of this is quite dull. So there's quite a lot of black and dark grey on there. And I'm going to cut it open so you can see the difference once it's been cut. Now it is quite soft, but you can just about see there. Can you see now how shiny it is? So it's much more shiny once we cut it open. So I've got a couple of pieces there. I'm going to take a little bit more off that one. So we've got a couple of pieces to go. So that is lithium. So very soft metals, very shiny on the inside, but very quickly dulling. So we'll have a look in a minute at what the outside of those are looking like now. So next up in the group, make sure I've put the lid back on that jar. Next up in the group is sodium. So I'm going to get out another piece of sodium. So it's a very light in colour. Again, you can see that it's quite dull on the outside at the moment. Again, I'm going to dab it with a towel just to remove some of that oil. And again, you can see how dull the surface of this is until it is freshly cut. So I'm going to use a small piece again. I'm going to cut a couple of small pieces. Now this is much softer than the potassium was. And you can see again very quickly, they are very shiny once they've been cut, but this one is already beginning to dull and get that coating from reacting with oxygen to form an oxide. So I'm going to pop those to one side. So our final one is potassium, and again quite dull on the surface. So I'm going to get this one ready. Again, grabbing off some of the oil and cutting some small pieces. So you can see how soft this one is now. It's like cutting through cheese. It is extremely, extremely soft. And again, shiny surface where it has been freshly cut, but much duller on the other surfaces. So we're going to get these ready now to add one by one into our glass bowl. So now we've got our pieces of the metals ready, we're going to do the exciting part. We're going to add them into the water. I've got a second camera that's a little bit more zoomed in, so hopefully we'll be able to get a good idea of the reactions that are going on whilst we do this. So we're going to start off at the top of the group with one of our pieces of lithium. So I'm going to do it once, just dropping it straight into the water, and once onto some filter paper, just because it gives you a little bit more of an idea of the reaction. You can sometimes see it a little bit better. So I'll be doing each one twice. So first of all, I'm going to drop the piece straight in, and you can see it start to fizz around on the surface of the water. Now, some of the other properties I'll discuss while this one is reacting, they have a very low density, and you can see that because it's actually floating on the top of the water. Normally with metals, we'd expect them to sink straight to the bottom, but our group 1 metals will float on the surface. So lots of fizzing and moving around. You may also be able to see on the video that there is some steam produced, and I'll talk about that a little bit more in a second. So I'm going to do it again. I'm going to drop a piece of filter paper in, and we're going to add another piece. So you can see it does start reacting. It has started reacting. It's a little bit slow with the filter paper, but you can see it's still moving around, still fizzing. So in a second, you should be able to see some steam produced. I can see it's being produced now. It may not be picked up on the camera. Now, one of the products of this reaction is hydrogen, but hydrogen is a colourless gas. We can't see it. What you're actually seeing is steam from the water in the bowl. So this is a very exothermic reaction. It gives out lots of heat, and it actually causes the surface of the water to boil a little bit and produce a little bit of steam, which is what you're seeing. So it's not smoke, it's not hydrogen, it is steam from the water in the bowl. So the next one we are going to take a look at is sodium. So again, I'm going to start off by dropping a piece in, and we're going to have a look at how its reactivity compares to the reactivity of the lithium that we have just been looking at. Just choosing the right size piece. So you can see very, very quickly it is reacting. It's melted into a small ball, and it's moving around quite quickly on the surface of the water. Now this illustrates another of our properties of the group 1 metals. They have a very low melting point. Again, the heat being produced by this reaction has been enough to melt that sodium into a ball. So it's moving around and it's fizzing, and we sometimes get a little bit of a pop at the end. We'll wait and see if that happens. Might not with this one. It's still going, still moving around. Still going. So it's just a tiny little ball now, still moving around. Right, no, so it's not really popped that time, okay? So what I'm going to do that sometimes shows the reaction a little bit better is I'm going to drop in the filter paper again, and I'm going to drop in a piece of sodium. So I'm going to step back for this. So we can see it reacting very quickly, melting into a ball, lots of steam being produced, and this characteristic yellow flame. So sodium always burns with a yellow flame. It's one of those characteristic things. And you can see there that, again, the heat, there's the little pop, the heat from the reaction itself has been enough to ignite the sodium and allow it to burn with this yellow flame. Now, you will have seen at the end there was a little pop, a little explosion. That is, again, the heat from this exothermic reaction causing the hydrogen that's produced to ignite. So if you remember our squeaky pop test, which is a test for hydrogen, that's why you get that little explosion and that little bit of a pop at the end of that experiment there. So you can see as well, much more reactive than lithium was. So we're going to do our final experiment today. We are going to look at potassium. So again, I'll do it the same. I will do a piece straight into the water, and then I will do a piece onto the filter paper as well. And again, we can take a look at how reactive this is compared to the others. So very, very quick reaction this time, straight away, purple flame, and very quickly explodes. So again, igniting that hydrogen that we've got. I'll add in the filter paper. Hopefully it'll slow the reaction a little bit, and you'll be able to see the reaction a little bit better. So let's try this piece. So again, that characteristic purple flame, and a little bit of a pop from it igniting the hydrogen at the end. So that flame, that lilac flame, if we're being specific, is very characteristic of potassium. Potassium will always burn with a lilac flame, and you could see it there. So again, the heat of the reaction was enough to cause the lithium to actually catch fire and burn with that purple flame. Now, the final thing I'm going to show you is why these are called the alkali metals. So each of these reactions has produced the hydrogen we've talked about, but also a metal hydroxide. So we've produced lithium hydroxide, sodium hydroxide, and potassium hydroxide. And these are all alkaline in solution. So what I've got is I've got some universal indicator. I'm just going to pour it straight in and we're going to look at the colour. And you can see there this lovely dark blue.
This dark blue colour tells us that we have an alkali in our solution. So that would be our hydroxides. And that is why these metals are called the alkali metals. So to summarise, we can see from these three reactions that as we go down group 1, the alkali metals get more reactive. So lithium just kind of floats around on the top, whereas sodium, once it gets going, burns with this characteristic yellow flame. Much quicker reaction and also much more vigorous than the reaction with lithium. And then of course potassium almost immediately burns with this bright lilac flame. Very reactive and the most reactive in the group. Thank you very much for watching this video today.